in Desmos with students, and so when we put it in, we put negative 2x plus 8.5 instead of 8.5 minus 2x. It's an equivalent expression. We just put the x values first, and we put negative 2x plus 11 for the width. And when we graph that, you can see that it's a cubic function. And if you multiplied all those back together, it would be x to the third. And we also talked about how multiplying all those back together would just make it more difficult to solve. In the calculator it wouldn't. You could put it in either way. It would just provide more work trying to multiply it together. So putting it in just the way it is fine. You can easily see that the maximum point is right here. If you actually bring up a table, you push this gear button, it brings up a table for you. Even in the calculator, the TI Nspire CX that we use, you still can't see the decimal values. You can see that the maximum value, we had already tested out, some of the students had done the t-table by hand, and they knew that at 1.5 was a higher maximum volume, more than 1 or 2. But when you actually look at the graph, you get a more exact answer. You can see that the highest point is, the maximum volume is actually 66.15 when x is approximately 1.59. And so the calculator is more exact in giving that volume, more so than just plugging in, because it would be difficult to try out or test out. 1.59 was not a value you would think of. I talk about in the intercept form, this is you can see that the x-intercepts are the zeros of the function, which we'll talk about more later on in this unit, are 0, 4.25 times 2 is 8.5, so you get negative 8.5, subtract from 8.5 is 0, and 5.5 times 2 is 11, so your x-intercepts are easily to see also. But the maximum volume is 66.15, and when x is approximately 1.59.